Hello students, this is Mr. Damiani, and today we're going to be looking at lesson 10.9, which is located on page 583 in your chapter 10 workbook. The topic for today's lesson is going to be figures on the coordinate plane. So we are going to be graphing some points on a coordinate plane. You could be asked to find the area of the figure after or find the perimeter. So we're definitely going to be pulling in our knowledge of how to graph points on that plane. The central question: how can you plot polygons on a coordinate plane and find their side lengths? All right, so we're going to go ahead and scroll down here and unlock the problem. The world's largest book is a collection of photographs from the Asian nation of Bhutan. A book collector models the rectangular shape of the open book on a coordinate plane. Each unit of the coordinate plane represents 1 foot. The book collector plots the vertices, or what a vertex is, that's a corner or a point, of the rectangle at A, 9, 3, B, 2, 3, C, 2, 8, and D, 9, 8. What are the dimensions of the open books? All right, so what dimensions do you need to find? All right, so if we're dealing with a rectangle, then we're going to be looking at finding a length and width. All right, of the rectangle. So let's go ahead, adjust that a little bit. Read the directions. Plot the vertices and find the dimensions of the rectangle. Step 1, complete the rectangle on the coordinate plane. We need to plot points C, 2, 8, and D, 9, 8, because A and B have already been plotted. Then we're going to connect these letters together to form the rectangle. So we're going to go ahead and plot point C at 2, 8, over 2, up 8, place your dot, and let's label that point C. And we're going to count over 9 and up 8, and we're going to label that point D. So we have our 4 points located on our grid, and we're going to go ahead and connect those dots to form the rectangle. Step 2, find the length of the rectangle. All right, so our length is going to be the distance between A and B. So we have an option here. We can count on the grid, or we can apply concepts of absolute value, which I'll show you down in a few seconds. So the y coordinates are the same here. So the points lie on a horizontal line. All right, and we have 2 options. If the figure is on the grid in front of us, we can count the length of A to B. So 1, 2, 3, 4, 5, 6, 7. So I have an answer of 7 for the length of A to B. If the grid's in front, we can count, and if you can count correctly on the grid, then you're going to apply that strategy. If we're going to apply absolute value, what we're going to do, since we're traveling within the same quadrant, we're going to use a form of subtraction between our points. So if you look at A and B, you notice the y coordinates are the same, so we're going to look at our x coordinates. Our x coordinates are the 9 and the 2. I'm going to find the absolute value of 9, which is 9, and the absolute value of the 2 for point B, which is 2. Now, since the points fall in the same quadrant, we are going to subtract. So remember, this was from back, I want to say chapter 3. Same quadrant means subtract. Different quadrants mean add. So subtract to find the distance from A to B. 9 minus 2 equals 7. You will always use the 2 numbers that are different to find the distance. So in this case, we use the 9 and the 2 instead of the 3. So the length of that rectangle is 7 feet. Now let's go ahead and move on down to step 3. Find the width of the rectangle. So again, I'm looking for the distance between C and B or D and A. I can count this out on the grid. Okay, so if I count that out on the grid, I'm going to say 1, 2, 3, 4, 5. I get a distance of 5. If I don't have the grid available, I'm going to apply concept of absolute value. So let's do that without looking at the grid. Find the distance between point C and B. The x-coordinates are the same. They both are 2. So the points lie on a vertical line. It means up and down. So I'm going to focus my attention on the 2 numbers that are different, the 8 and the 3. I'm going to find the absolute value of 8 and the absolute value of 3, and I'm going to subtract to find the distance between. So the vertical distance of C from 0, absolute value of 8, is 8, and the absolute value of 3 is 3. So I want to go ahead and take the difference between these two because, again, same quadrant means subtract. We're in quadrant 1 here. So we're going to subtract these differences. 8 minus 3 gives me 5. So you have the grid approach or you have the absolute value approach to answer the questions. So the dimensions of the open book are 7 feet by 5 feet, the length and the width. All right, let's go ahead and turn the page, please, to page 584. All right, thanks for getting yourself set up here. We're going to make a connection here to some stuff we've already talked about, so please follow along. You can use properties of quadrilaterals to help you find unknown vertices. The properties can also help you graph quadrilaterals on a coordinate plane. So for example, if we're trying to graph points of a rectangle, we have to remember that opposite sides are parallel and equal. Same thing with a parallelogram. All right, so these are some things that we need to just remember as we try to graph some figures on that coordinate plane. All right, first example, find the unknown vertex, unknown corner, the unknown point, and then graph it. All right, so here it goes. 3 vertices of parallelogram PQRS. This is labeled by the points. So PQRS are the 4 points of that parallelogram, and P is 4, 2, Q is 3, negative 3, and R is negative 3, negative 3. Those are the 3 points we're given. Give the coordinates of vertex S. So I have to find vertex S, and then graph the parallelogram. All right, here it goes. Step 1. Plot the given points on the coordinate plane. So we're going to go ahead and scroll down here a little bit, and we're going to plot P, Q, and R. So let's start with P. 4 spaces to the right, up 2. Over 4, up 2. That gets a P. Q is 3 to the right and down 3. So that's a Q. Label that accordingly. And R is negative 3, negative 3. So that's to the left 3 and down 3. And that is point R. I need to find point S. So let's get into step 2. The opposite sides of a parallelogram are parallel. They have the same length. So we talked about this right in the beginning of this page here. So opposite sides of a parallelogram are both parallel and equal, the same length. Since the length of side RQ, so we're going to find the side of RQ. So let's go to our graph here. And let's find the distance between R and Q. Remember, you have 2 different ways of going about this. You can find by counting on the grid, 1, 2, 3, 4, 5, 6 units, or you can go up to R and Q. And if you notice here with RQ, the ordered pair for R is negative 3, negative 3, and the ordered pair for Q is 3, negative 3. So the different, these ones are the same, so the different coordinate is the x-coordinate. So I'm going to use the negative 3 and the negative 3. They are in different quadrants. If you know down here, R is in quadrant 3 and Q is in quadrant 4. So those are in the different quadrants. So we're going to add the absolute values together. The absolute value of negative 3 is 3. Absolute value of the negative 3 is 3. So 3 plus 3 is 6. That's another way to get your 6. Or you can count on the grid. So the length of side SP, so if RQ is 6, then that means SP must also be 6 units. Okay, so what we're going to do is we're going to start at point P, and we're going to move horizontally to the left, and we're going to count off 6 units. Okay, so here we go. 1, 2, 3, 4, 5, 6. Place your dot, label it your S. There's your point S. So we started at point P and we moved horizontally 6 units to the left, just restating what I did, to find the location of the remaining vertex S. We plotted that point with an S. Now I'm going to play connect the dots here, and we're going to actually form that parallelogram in red. All right, so we drew the parallelogram, opposite sides were parallel and congruent. So that means the coordinates of vertex S are, let's count back to the left, -2, +2. Perfect. What I'd like you to go ahead and do now is turn to page 585. We should be looking at the share and show. All right, so we're going to go through question 1, and I'm going to ask you to answer some questions on your own for tomorrow. All right, question 1, share and show. The vertices of triangle ABC are A equals -1, 3, B equals -4, -2, and C equals 2, -2. Graph the triangle, step 1, and find the length of BC, step 2. So you have 2 things we want to accomplish here. So let's start by graphing the triangle. We are going to graph A, B, and C. So point A is 1 to the left, up 3. So there's your A. B is 4 to the left, down 2. There's your B. And C is 2 to the right, down 2. And that would be point C. Okay, so there is the graph of the points, and we are going to connect the dots to form my triangle. All right, looks good so far. The horizontal distance from B from 0, the absolute value, is going to be, we're going to use the absolute value of -4. What I want to do though is I'm just going to rewrite these points for B and point C. So I have a -4, -2 for B, and for C I have a 2, -2. All right, so now I'm notice that I'm not going to use the -2's here because they are the same. So I'm going to focus on my two other values here, this -4 and the 2. And -4 and a +2 tells me they're in different quadrants, so I know I have to add. So the absolute value of -4 is 4. The absolute value of the +2 is 2. Again, these come from right here. And I'm going to take those 2 points and I'm going to add them together to get my distance. So the distance would be 4 plus 2, 6 units. And that gets me the distance from B to C. Double check the graph. 1, 2, 3, 4, 5, 6. Matches up. We're happy. All right, so now we're going to bring our attention down here. What I'm going to have you do is go ahead, read the directions, and you are going to come up with the ordered pair for questions 2 and 3. Again, you're just finding the missing point. All right, and then the other one I would like you to take care of here would be question 5. All right, so you're going to graph some points on the coordinate plane, and you're going to have to find a length of a point down here. All right, so what I'd like you to take care of for me with my class as a reminder is you need a post-it note with that main idea and important information for the video lesson. And remember, if you have a question, always put it on a post-it note. The riddle for today is, what do you call a crushed angle? So the riddle for today is, what do you call a crushed angle? So hopefully you come to class tomorrow, you have that prepared along with the information for the video lesson, and be ready to work. Thank you. Have a great night. Goodbye.